Today we are going to cover chemical changes, topic 8 from the GCSE AQA CGP Chemistry Guide. In this topic we are going to cover chromatography, anion and cation tests, flame spectroscopy, chemically pure and impure substances, and tests for gas. Topic 8. Chemical analysis. The chemical definition of purity is a substance that only contains one compound or element that is not mixed with anything else. A chemically pure substance will melt/boil at specific temperatures. If this differs from the value given in the book, it is likely the substance is impure. The further the melting point from the original, the less pure the substance is. Impurities will lower the melting point and increase the boiling point, and increase the ranges for which the substance melts or boils. Formulations are mixtures with measured quantities of each ingredient, which contribute to its overall function. For example, paints contain pigment to give colour, solvent to make it runny, binder to hold the pigment in place, additives to change the chemical/physical properties to those desired, and many more to contribute to the function of the paint. Formulations are very important in the pharmaceutical industry to make pills with the right treatments and shelf life, but also to make cosmetics, fuels, fertilizers, cleaners, metal alloys, food and drink. Information on this can be found on the back of the packet to help you decide if the product is fit for purpose. Gases can be tested for in substances via the following methods. Chlorine bleaches damp litmus paper, turning it white. Oxygen will reignite a glowing splint when hovered inside a test tube. Carbon dioxide can be bubbled through calcium hydroxide and turn it cloudy. Hydrogen in a test tube will make a squeaky pop when burnt, when a splint is put inside. In paper chromatography, there are two phases for the particles involved. A mobile phase, where molecules can move, and a stationary phase when they can't. So depending on the original compounds depends on how long they stay dissolved in the liquid, and thus separate out if they are in different compounds. A pure substance will only ever leave one dot on the paper. The time they spend in a solvent depends on how soluble they are to the solvent, and how attracted they are to the paper. For example, a higher solubility and less attracted to the paper will go further. The result of chromatography is called a chromatogram. The RF value is the distance travelled by a substance divided by the distance travelled by the solvent. You can see if there is a specific compound in a mixture by comparing the two chromatograms' RF values. If so, there may be a match. The RF value can change though depending on the solvent used. So repeating with many different solvents, and then if the RF value matches for all of them, then that compound is definitely present in the mixture. But if some of them don't match up, then they are not the same compound. You can also test to see if a substance is an anion. Carbohydrates can be tested for by adding dilute acid and bubbling through lime water to see if it turns cloudy. Sulfate ions can be tested for by adding HCl and then barium chloride to see if a white precipitate, barium sulfate, is made. Halides can be tested for by adding dilute nitric acid and then silver nitrate solution. A chlorine will make a white precipitate, bromine will make a cream precipitate, and iodine will give a yellow precipitate. Make sure to remember this, as examiners frequently put these kind of questions in exams. Cations can also be tested for. Burning metals in a Bunsen burner can produce certain colours that are important to memorise. Lithium is crimson red, sodium is yellow, potassium is lilac, calcium is orangey red, and copper is green. This can be done by cleaning a platinum loop in a flame and then dipping it in the metal powder you're testing before burning it again. This only works for pure metals, however. Some metals can also make a coloured precipitate when reacted with NaOH. Calcium turns white, copper turns blue, iron 2 turns green, iron 3 turns brown, aluminium turns white at first, but then goes colourless, and magnesium is also white. Flame emission spectroscopy is where a substance is burnt and a line spectrum is produced. The combination of wavelengths emitted and shown depends on the charge and electron arrangement, of which no two atoms have the same, so it is possible to identify ions, and the intensity of the colours can also indicate the concentration. This also works for mixtures, making it more useful in most cases than a flame test. A computer can also quickly and accurately tell exactly which ions are in a line spectrum, far faster than a human can. Thank you so much for watching this video. Like, subscribe and share to see more content.